So very good morning, dear students. We are continuing with the 3.7 exercise. Okay, this is the first question we are going to do. Prove that tan x plus cot x is equal to 2 cosec 2x and deduce that tan 75 plus cot 75 is equal to 4. We have to prove. So first of all, let us prove this question and then we'll deduce this thing. Okay, so I've taken this LHS tan x plus cot x. Tan x can be written as sin x upon cos x plus cot x can be written as cos x upon sin x. Now taking LCM, so sin square x plus cos square x upon cos x sin x. This will be 1, so 1 upon cos x sin x. Now as we have the identity of sin 2x as 2 sin x cos x and we have sin x cos x only here, so I'm multiplying 2 and this 2 in the numerator and denominator, so this will become sin 2x and this 2 is as it is, and when this sin 2x will come up, so it will be 2 cosec 2x. So hence we have proved. Now so tan x plus cot x will be equal to 2 cosec 2x. Now if x is equal to 75, then tan 75 plus cot 75 is equal to 2 into 75, which is 150 degree, so 2 cosec 150 degree. Then we can write this 150 degree as 90 plus 60. Alright, and we know that cosec 90 plus theta is what? Positive of sec theta. So sec 60 degrees, sec 60 degrees 2, so 2 into 2 will be equal to 4, like that. Okay, let us understand this question. So this question says that sin x upon a is equal to cos x upon b, then prove that a sin 2x plus b cos 2x is equal to b. We have to prove. This question, if such type of questions come, then you know it's better to use the K method, and which we already studied in the 10th class. The K method, how we solve the question in the ratio and proportion chapter. Okay, so consider this is equal to K. So sin x upon a equal to K, so sin x will be equal to AK and cos x will be equal to BK. Now let us take LHS. So a into sin, first of all, sin 2x is 2 sin x cos x plus b cos 2x is what? Cos square x minus sin square x. You can use any of the identity like 1 minus 2 sin square x or 2 cos square x minus 1. Okay, but I'm using this one. Alright, so a, then 2 sin x is what? AK, and cos x is what? BK. Plus b, as it is this cos square x we can replace it with bk, so b square k square, and here a square k square. So this is 2 times of a square b k square plus multiply b inside, so b cube k square minus multiply this b here, so a square b into k square. Now this 2 times of a square b k square minus of a square b k square, this will give you 1 time of a square b k square, and this b cube k square here. From these two you can take b k square common, so you'll get b square plus a square. Now we want that b should come, but here b is not coming. So what we are going to do, we need to replace this k square. So let us find the value of k square. Now you understand how I find the value of k square. As you have sin x is equal to ak and you have cos x is equal to bk. Let me square this equation. So what will get? Sin square x will be equal to a square k square, and let me square both the sides here. Cos square x is equal to b square k square. Now we have a relation of sin square x plus cos square x which is equal to 1. So let us add both the equations. So LHS plus LHS will get added, that is sin square x plus cos square x, and RHS will be getting added, b square k square. Okay, now this will be equal to what? 1, and from here you can take k square common, so in the bracket you will get a square plus b square, and you take here in the down, so finally you will get the value of k square as 1 upon a square plus b square. Okay, now just substitute the value here, so b into 1 upon a square plus b square, and this is a square plus b square only, which is you can cancel easily, and finally you will get b as a answer, which is the required proof. Okay, let us come to this question. It says that tan y is equal to 3 tan x. We have to prove that tan x plus y is equal to 2 sin 2y upon 1 plus 2 cos 2y. Okay, so from the given part, what I'm doing, see, first of all, you just see one thing, which is like we should note, you are asked to prove tan x plus y is equal to 2 times of sine 2y upon 1 plus 2 cos 2y. See, your RHS is totally in terms of y. There is no x term in it. And you have to prove tan x plus y is equal to so. So from here, what I'm doing, I'm taking out the value of tan x as tan y upon 3. Because when I'll use the identity here in the LHS, the tan x plus y, which is tan x plus tan y upon 1 minus tan x tan y, and I need to, this x term should not be there. So that is what here we are doing, tan x is equal to tan y upon 3. So we can replace this tan x value with tan y upon 3. Okay, so I'm replacing this tan x by tan y upon 3 plus tan y as it is upon 1 minus, this is, I've taken LHS, okay, or taking LHS. Alright, so I have used the identity here, replaced the value of tan x as tan y upon 3, and here also in the denominator. Now take the LCM, so this 3 will be multiplied here, so 3 tan x whole upon 3 and whole upon, multiply this 3, so 3 minus, this will be tan square y upon 3. This 3 with this 3 you can easily cancel. Tan y plus 3y will give you tan y plus 3 times of tan y, 4 tan y, and 3 minus tan square y. Now I have changed this tan y as sin y upon cos y, and this tan square y as sin square y upon cos square y. Now you take the LCM in the denominator, so this will be 3 times of cos square y minus the sin square y and whole upon cos square. This one cos with this one cos will be cancelling. I'm solving here. Okay, so this one cos y is left, it will go up and will be multiplied with this sin y, so 4 sin y cos y upon 3 cos square y minus sin square y. Now please try to understand that how I'm molding this question to this direction. Okay, now we want 2 times of 2y sin 2y here, so this 4 can be splitted as 2 into 2 and sin y cos y. Okay, and here we want cos 2y. See, can we use cos 2y as cos square y minus sin square y identity? But this 3 is there with us, so how I'm splitting this? Can I write this 3 cos square y as 2 cos square y plus cos square y? Can we? Yes, we are correct, because 2 cos square y plus cos square y will give you 3 times of cos square y. Okay, now this can be written as 2, this 2 as it is, and 2 sin theta cos theta is sin 2 theta, so sin 2y. This is as it is, cos square y. Okay, you can write this thing as, how can you write this thing? You can write this thing as, how can you write? This is cos 2y. Okay, because cos square y minus sin square y is what? Cos 2y. So like this we have written, but still we are not like, it is not looking like our proof. In the proof, and also in the denominator, we have 1 plus 2 cos 2y, but here it is looking like this. So what I am doing, as we know that cos 2x is what? 2 cos square x minus 1. We have 2 cos square x, but we don't have minus 1. So what I'm doing, I'm in the denominator only, I'm adding plus 1 and minus 1. Okay, now this 2 cos square y and minus 1, this will give you cos 2y. So cos 2y plus this cos 2y and this plus 1, which is I have written like this. Okay, understood? See, just to make, this was not there, so this is not looking like this. To as in the proof you have two times of cos 2y, but we have only one time. And one formula we know that 2 cos square y minus 1 will give you 2 cos 2y. That is why we added 1 and subtracted 1. So 2 cos square y minus 1 will give you cos 2y. So cos 2y and this plus 1. And this cos 2y plus cos 2y will give you 2 cos 2y. So 2 cos 2y plus 1. Hence proved. Okay, now please try to understand this question. Sin 5x is equal to, we have to prove 5 sin x minus 20 sin cube x plus 16 sin to the power 5x. So we have to prove sin 5x as this quantity. So we are writing this sin 5x as sin 3x plus 2x. Now we can use the identity sin x plus y, that is sin x cos y plus cos x sin y. So we have used here. So sin 3x will give you 3 sin x minus 4 sin cube x, which we already know, and cos 2x is 1 minus 2 sin square x. We are using that sin 1 identity in terms of cos 2x, and cos 3x is 4 cos cube x minus 3 cos x, and this sin 2x is 2 sin x cos x. Now I have multiplied these two brackets to get this four expressions. Okay, I have multiplied these two and we got this as the result, and plus sign, and from this bracket I have taken cos x common. So 4 cos square x minus 3 cos x, and this 2 sin x cos x, which is going on. So as you see that this cos x, this 2 can be multiplied and they will give us cos square x. So in this step only I'm writing this cos square x like this. Now this will be same, 3 sin x minus this 2 will give you minus of 10 sin cube x plus 8 times of sin to the power 5x plus, now in place of this cos square x you can write 1 minus sin square x, and in place of this cos square x also again you can write the same thing. So how? And when you multiply this 4, see, in place of cos square x I'm telling you to write 1 minus sin square x, the identity, and when you multiply 4, so inside, so 4 minus 4 sin square x you will get, and this 2 I'm writing here, and here this sin x I'll write sin x. Okay, in place of this cos square x, 1 minus sin square x, and this sin x here. Okay, now what you do, 4 minus 3 will give you a 1, so here I'm writing it as 1. Okay, now multiply this 2 sin x in this bracket or in this bracket, and multiply this 2 bracket and just solve it. You will surely get this quantity, 5 sin x minus 20 times of sin cube x plus 16 sin to the power 5x. Okay, let us come to this question. This says that sin square 24 minus cos square 6, sin square 24 minus sin square 6 is equal to, we have to prove root 5 minus 1 upon 8. So what we are doing, we are going to use an identity here, and that identity is cos square x minus sin square x, which is equal to cos x plus y into cos x minus 5. That identity we are going to use in it. So for that, here we need this first term as cos square x. So I'm writing this as 24 as 90 minus 66. This sign is as it is, and as in this is a square, so I'm writing the whole square. Okay, and minus sin square 6, which is going on, and we know that sin 90 minus theta is what, cos theta, so cos 66, and this square, so cos square 66 minus sin square 6. Now as I told you, cos square x minus sin square x, which is the easier identity we can use in this question, so that is why we are using it. All right, so cos 66 plus 6 and cos 66 minus 6, this is 72 and this is 60 degree, cos 72 degree, cos 60 degree. Now this 72 again you can write as 90 minus 18 degree, so cos as it is, 72 can be written as 90 minus 18, and this cos 60 as it is. Cos 90 minus theta is what, sin theta, that is sin 18 degree, and the value of cos 60 degree is what, half. And we already have seen the special angles, that is of sin 18 degree, which is root 5 minus 1 upon 4 into 1 upon 2, so root 5 minus 1 upon 8. That is the answer. So that's it for today's video. 5 to 6 questions I have explained you, and all the questions are different. So why I have explained you the different questions, so that you can do the similar kind of those questions. And especially please focus on the examples. If you face any example, then please try to ask the doubt in it, and also solve the exercise question. This questions I'm solving the exercise question and I'm not taking the examples. So I consider that you should do the examples, because in the examination the main focus is like from the examples only. The question comes from the examples, okay, and not less from the exercise. So try to focus on them also, okay. And that's it. Thank you so much.